Had to take a guess. What do you think the topic of our lesson is going to be about? I'll give you a clue. Any ideas? What do you think we're going to be discussing today? I'll give you a really big clue. It's right, parallelograms. Now, I just want you to know that this comes to you in your Math Nation book, Units 8.1 and 8.2, Properties of Parallelograms. And our objective is to be able to find missing angles and sides of a parallelogram. So, when we talk about the properties of parallelograms, what does the word property mean in the context? In the context of this, if we say the properties of something, what do they mean? Anybody? Well, property. What's another word for property in this usage? Nobody knows? They can't hear you on the microphone. You could speak. How about if I said, what are the properties of a good student? What would you say? What are some of the properties of anything? That means what are the characteristics, the qualities? Like the characteristics, the properties of a good student. They come to class on time, they're prepared, they're polite, they do their homework, those kind of things. What are the properties of a parallelogram? Well, that's what I'm going to talk to you about. And I'll let you come up with your own definition of a parallelogram. But look at the root word there, parallel. So I'm going to talk to you about the properties of a parallelogram. But first, I want to show you how most people typically illustrate or draw a parallelogram, a representative of a parallelogram. They usually draw like a little slanted line, like right here. And you could do this on your paper. And then they'll draw like a horizontal line. And then they'll drop another slanted line. And notice how I try to make it parallel to the first line. It's not perfect. I'm the worst artist on the planet. But that's usually what a parallelogram will probably look like. Now, when we talk about the properties, it's the qualities, characteristics. The one most important, the first one, and this is not in any particular order, but the first property of a parallelogram is that, copy this down. What do you think I mean when I write OPP? Yeah, thank you for that. Opposite sides are. Do you remember when you have an equal sign that goes up and down? Does anybody know what that means? An equal sign that kind of like looks like that? Look at this right here. See that part of the word I'm underlining? That's what that means. Opposite sides are what? Yeah. See how I'm putting a box around the word parallel? The symbol for parallel is like it looks like an equal sign that's almost vertical like that. In a parallelogram, opposite sides are parallel. Opposite sides are parallel. So write that down. Write it down, man. Now, when you write that down, I'm going to go back to it, but watch what it means. If opposite sides are parallel, you go back to your diagram, and you look at the diagram and you say, oh, an example of a pair of opposite sides would be the top. What's the opposite side to the top? Don't be shy. What's the opposite side of the top? The bottom. So if opposite sides are parallel, that means the top is parallel to the bottom. That means like railroad tracks. And the way you show that two lines are parallel or two segments are parallel is arrows. You use the same number of arrows. In other words, if this top is parallel to this bottom, then if I put two arrows on the line like right here, then how many lines do you think I'm going to put on the bottom side? Well, it's got to match. Because anytime the number of arrows match, that means they're parallel. Just like two railroad track, two lines on the railroad track. So now If it says opposite sides are parallel, not only is the top parallel to the bottom, but guess what? The left side is parallel to what? Opposite sides are parallel. What is the left side parallel to? Yeah, what is the opposite side of the left side? The right side. Now, if I want to show that these two sides are parallel, what can I use to show they're parallel? I'll give you a clue. Arrows. Now, I'm only going to put one arrow. Notice how that side has one arrow and that side has one arrow? Do you know why? Because I want to show that these two sides are parallel without indicating that this side here, the left side, is parallel to the top. So the top and the bottom are parallel to each other. That's one pair of parallel sides. And the left side and the right side are parallel. Okay, any questions with that? Raise your hand if that's kind of easy to understand. No? Well then, the other property I want to put in the same sentence. Let's go back over here. Not only are the opposite sides parallel to each other, but they're also this symbol. Can anyone tell me what that stands for? What is it? Someone said it. Well, when it's equal with a squiggly line, that means what? Congruent. And trust me, if two line segments are congruent, then they're equal in length. And if they're equal in length, then they're congruent. So here's the point. Opposite sides are parallel to each other and congruent to each other. Write it down. Write it down. Did you write it down? Now, how do you show that graphically? You show that by saying, well, remember when we used the little slash marks? Like the top is opposite the bottom. And since this is a parallelogram, not only is the top parallel to the bottom, but it's congruent. And we could do that by showing slash marks. Like if I put one slash mark here, how do I show that this is congruent to that? Put a single slash mark. That's a pair of congruent sides. They're opposite sides. They're congruent. What about the left side and the right side? Are they congruent? Well, yeah, because opposite sides are congruent in a parallelogram. How do I show that these two sides, left and right, are congruent? Can I use one? No, and why not? Because we don't want to give anyone the impression that the left side is congruent to the bottom or the top. We just want to say, okay, there's something under here. We just want to say that the left side, so I'll give it 2 marks, is congruent to the right side, so I got to give this 2 marks. So when the number of marks match, guess what? They're congruent. Any questions with that? Okay, the next one I want to talk to you about. Here's one for you. You see what that says? What do you think that says? Opposite angles are what? Congruent. Now, let me tell you what they mean. Write that down. I want to show you what it means graphically. Then we're going to go on to the problems. We'll be done in just a few minutes. This does not take long. Check this out. Opposite angles are congruent. You go back to the diagram. Back to the diagram. Opposite angles means like, well, consecutive angles are next to each other, like these two are consecutive and these two are consecutive, one right after the other. Opposite, the angles that are opposite would be those non-consecutive angles. Like if I said, what angle is this one congruent to? And I'll put one arc here. This is consecutive because it's right after. This is consecutive because it's right after. They're next to each other. But the opposite angle to this would be the one way across on the other side of the parallelogram. And if I want to show that they're congruent and I put one arc here, how many arcs do I have to put here? One. I put one arc here and one arc here because opposite angles in a parallelogram are congruent. Now, what about these two? They are opposite angles, so they're congruent to each other. What do I do to mark that? Is that good enough to use? Well, if I use that, it's also saying it's congruent to this angle. But I really want to just say that this angle is congruent to this angle. So instead of using just 1, I would put 2. Because when I put 2 here, and I put 2 here, what I'm saying is, yo, these 2 angles are congruent to each other, but not congruent to these 2. Any questions with that? So that's when we say opposite angles in a parallelogram are congruent. Like if this were, say, 50, what would that be? And you'd say 50. Next. One of my favorite ones, I'm just making that up, it's not really my favorite. Check this out. Consecutive angles are, I hope you remember this word. I'm abbreviating it. See that word right there? What does sup stand for? Supplementary. Write that down. What do you think supplementary means? It adds to a very special number. What number is that? It is 180. Now we're talking about angles. So consecutive angles are supplementary. What that means is, okay, writing that down, writing it down. Right. Yep. What that means, class, is that if you look at the diagram, I'll go back to that so I can finish copying. Consecutive means 2 angles that are right next to each other, one right after the other. So like this angle here in the corner, and this angle right here in the upper corner, those are consecutive. That means one right after the other. That means they're supplementary. Just for an example, supposing that was 100 degrees. What do you think this angle down here would be? Consecutive angles are supplementary. So if this is 100, what does this have to be? Oh. Okay, so if this is 100, remember, 2 angles next to each other have to add up to be 180 degrees. So if this was 100 degrees, just saying, what would that angle be? 80, because 100 plus 80 is 180. That's what makes them supplementary. And since that's 100, then this would be 100. Okay, now, because opposite angles are congruent. Let me move on. The last one I'm going to write for now is this. The diagonals bisect each other. Oh, this is a fun one. The diagonals bisect each other. Write it down. Write it down, please. We're almost done. So diagonals bisect each other. Let me explain to you something about the diagonals. A diagonal of any polygon is a line that connects non-consecutive vertices. Like a diagonal would be a line segment that connects this vertex to the vertex all the way on the opposite side, because they're non-consecutive. Another diagonal would be from this vertex all the way to this vertex. And what I'm telling you is whenever you draw the diagonals of a parallelogram, they bisect each other. They're both cut in half, so that makes this the midpoint of both diagonals. If this diagonal is being bisected, that means this half right here, and I'll put 3 little tick marks. 1, 2, 3. That means this little half right here is equal in length to this half right here. So I'll put 1, 2, 3. Like, for example, if this were 10, what do you think this side would be? 10, because they're equal. Now, that means that this diagonal is also bisected. So if I put, like, say, 4 marks here, 1, 2, 3, 4. How many do I have to put on this side? 4. Now I have a trick question for you. If I told you that the distance from this to this was 40, from here all the way to there, what do you think this distance right here would be? Well, I heard someone say 20. And what would this be? 20. Because these two are equal, and if the whole entire length is 40, then one side would have to be 20, the other side would be 20, because 20 plus 20 is 40. Awesome. Now that's kind of confusing, so let's take a look at our first problem together. Right there. Now, I want you to be able to find the missing pieces, because that's the objective. But I also want you to be able to justify why you're writing what you're writing. And when I say why, I'm really asking you to recite one of the properties. You are to recite, repeat, just verbatim. Like, for example, if I said to you, what is, oh, well, wait a second. Look at the first question. What's AD? What does it mean when you have an A and a D next to each other with nothing above it? That's the question. You got to remember, what does it mean when there's nothing over the AD? Anybody? 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 When there's nothing above the AD, does it mean line segment AD? Does it mean line AD? Does it mean ray AD? What do you think it means? Somebody. Nope. Because if it's line segment, it would have line segment over it. If it were line, it would have a line over it. If it were ray, it would have a ray over it. But what does it mean when there's nothing above the A and the D? Think about it. Wait, what? It's the side AD. But what do they want to know about the side AD? They want to know, what do you think they're asking for? Say again? What the what? Yeah, the side number. Okay, fine. The distance. Whenever you see two letters next to each other, it means the distance from A to D. They want to know the length of AD when you don't see a line segment over it. So what do you think the length of line segment AD would be? And if you want to know, or you're not sure, look at all of these properties and see which one can relate to the side. Now, if you're talking about 180, that's angles, but we're not talking about angles. What's that say? It's 8. Look at opposite sides are parallel and congruent. So we recall. We look at this and we say opposite sides. If I want to know this length, what do you think it's going to be? What is AD the opposite of? BC, which is 8. So guess what? Since opposite sides of a parallelogram are congruent, and this side is 8, then this side is 8. So AD is 8. What do you think DC would be by the same token? It'd be 15. So if I say, why is AD or DC 15? Because opposite sides are congruent, and the opposite of the bottom is the top. Those are the same. So DC is 15. Whether it's 15 inches, 15 miles, 15 feet. Now it's asking for angle A. Well, angles C and A are congruent, but how do you find the numerical value for the measure of angle A? Well, you have to go back and look at what they give you. They give you the angle D. So let's see what they say about angles. Opposite angles are congruent. Opposite angles are congruent, but consecutive angles are supplementary and add up to be 180. So let's take a look at, because they do give you the measure of angle D, which is 68, and they're looking for A. What do you think they are? Do you think they're opposites or are they consecutive?
Consecutive.
Sure, they're consecutive. So class, since consecutive angles are supplementary, what do you think A has to be? That's correct. Because if these two have to add up to be 180, then if we take 180 minus 68, we're talking about 112 degrees. That's got to be 112 degrees. Because what's 112 plus 68? 180, thank you. And consecutive angles are supplementary. As a matter of fact, we could put right now this is 112 degrees. Now what about angle B, which is way across on the opposite side? So what is B? Why? Because opposite angles are congruent. So guess what? I'm going to write it here too. That's 68. Angle C has to be 112. And for what reason?
Opposite side.
No, not opposite sides, but opposite. If that's 112, and then this is 112, but I said why?
Oh.
And someone said opposite sides, but it's not sides. They're talking about when you see the degree mark, the degree mark is talking about angles. Opposite angles are congruent. Okay, question? What'd I do? And I put 112 there? Oh my gosh. What the beep? Thank you. Sometimes the teacher got to be schooled. Now, any questions about that? Good, let's go to the next one. Looky here. There's a little piece of information down here or else you can't do the problem. It says the distance from R to T is 30. What can you kind of glean from the fact that R to T is 30? What other information does it give you?
It's opposite from.
I'm sorry, just raise a hand because. Anybody? Now remember, they're talking about sides only. If this whole thing is 30, what can you extract from that? What is 15? Yeah, so if you take 30 and divide it by 2, you get 15. Because remember, the diagonals bisect each other, so if the whole thing is 30, so it's 15 here and 15 here. Now they're asking for UT, which I ignored. Come on, kids, what's UT? 27. Why? Opposite sides are congruent. Amen. ST. Well, ST's right there. 18. Why? Opposite sides are congruent. VS, the distance from V to S. What's that? It's 7 because diagonals bisect each other. So if this side's 7, that side's 7. What do you think the whole length is from U to S? So VS is 7. I'm sorry, what is V to T? 15. But what do you think it is from U to S? Somebody said it. Yes, segment addition postulate. From here to here is 7. And then from here to here is another 7. So altogether it's 14. Just saying. Now listen. Your job, I'll try to work with you in class, but your only homework for tomorrow is to come in with this one done. This one's the homework, and this is for all classes. And this is this one. Now, you might not be able to do it, but let me give you a little heads up. This little line, and you see that bubble right there, that means you're talking about degrees, which means you're definitely talking about angles. And see where the line goes? That means that this angle is really 71 degrees. Over here, you see the little 21 with the bubble? and see the little arrow that's pointing to here? They're just saying that this angle right here is what number? 21. So if you get this one right, I'll give you extra credit. I really will, because I want you to have a struggle. So start with this one right now. They're all due tomorrow. Start with that one. You can work with a partner. You got a shoulder partner. You got to turn around, change your seat. Work with a partner. Get at least this one done, and outside, and just check, and I want to see if you did it right or not. So get started with those, and remember, opposite angles, opposite sides. You'll be done with that in a second. And I will be back with you in a few minutes. If you have a question, come up and ask somebody. I am stopping the video right